Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will discuss all the 4 problems asked in today's LeetCode Weekly Contest 468. So let's start with the first problem. It says you are given an integer array nums and you have to return the bitwise or of all the even numbers that is present in the array. And if there is no even number, just return 0, right? Yeah. This is a pretty straightforward implementation problem. So let's directly look at the code. So here is the code of first problem. So this is your nums array. So this is the size, and this is my or value. I mean the bitwise or of all the even numbers. Now what I'm doing, I'm going through all the elements from the array. I'm just checking if my current number is even, right? So you can check it by checking the modulo with 2. If the modulo with 2 is 0, it means that the number is even. If the number is even, just take the bitwise or value. So or equals to that number, that even number, right? And at the end return the answer, right? So yeah, this is the code of first problem. Now let's look at the second problem. In the second problem, you are given an integer array nums of length n and an integer k. Now you need to choose exactly k non-empty subarrays from the given array nums. Now these chosen subarrays may overlap, and the exact same subarray can be chosen more than once, right? So there could be repetition also. Now the value of a subarray from, let's say, nums L to R is defined as the difference between maximum and minimum element from the subarray. All right. Now the total value is defined as the sum of values of all the chosen subarrays, right? So it will be sum of all the differences in the chosen subarrays, and the difference is the maximum minus minimum, right? Now what you need to do, you need to return the maximum possible values that you can achieve, right? So yeah, this is a easy problem. Let's see how we can approach it. In the second problem, let's say this is my nums array, right? This is my nums array, and we have to choose k non-empty subarrays out of it, right? 1, 2, 3, right? K non-empty subarrays out of it, right? So now for let's say I have chosen some subarrays, right? We know that the value of that subarray is going to be maximum minus minimum, right? From the subarray, right? I'm going to ask you one thing. What is the maximum possible value which you can get? The max possible value would be, take the maximum value from the nums array and take the minimum value from the nums array, right? So that way you would get the maximum possible values. Take the max value and take the mean value. So the difference is the max possible, right? So that way you would get the maximum value, right? So let's say in the given array nums, there is a place where the maximum number is present, and there is a place where, let's say, the minimum number is present, right? So what I'm going to do, and one more thing, in the problem statement it says that these chosen subarrays can be repeated as well, right? So it's possible that the two chosen subarrays are exactly the same, right? So what I'm going to do, I'll first choose a subarray such that both of these mean and max is present. So that way your max value is going to be right, max value is going to be the maximum from the max value from I equals to 0 to n from the given array nums minus minimum from the nums array from index I is equal to 0 to n, right? So this is the max possible value. So take the maximum value from the nums array, take the minimum value from the nums array, and take a difference. So this is my max value. Now since it is possible that the two chosen subarrays could be exactly the same, I will choose the same subarrays k number of times, right? So your total value, the max total value is going to be k times this max value, and we know that the max value is equals to the maximum minus minimum from the original array, right? So it's pretty straightforward. The max possible answer is going to be k times max minus min, right? So this is the code. So you are given nums array and k is the given integer, right? So now the max possible value is the maximum element from the nums array minus minimum element from the nums array. So this is max value. Now what I'll be doing, I'll be choosing the exact subarray k number of times. So your total answer is going to be, your total value is going to be, maximum total value is going to be max value into k, right? So this is the code of second problem. Now let's look at the third problem. In the third problem, you are given two integer arrays nums1 and nums2, each of length n. Now you may perform the following split and merge operation on nums1, the first array, any number of times. So let's see what this operation does. So in one operation, you can choose a subarray, so you can choose any subarray. Now you remove that subarray, right? So let's say you have chosen a subarray from L to R. Now once you remove that subarray, what you will left with uh, numbers from 0 to L minus 1 and from R plus 1 to N minus 1. So this is your leftover array after removing subarray L to R. Now what you can do, you can reinsert this removed subarray at any position, right? And at the end, you have to return the minimum number of split and merge operation needed required to transform nums1 to nums2, right? So let's take the second example. So let's say this is my nums1 and this is my nums2. Now you can transform nums1 to nums2 within 3 operations. And in the first operation, what you can do, you can choose this subarray and you can insert at position 2. So once you remove this subarray, what you will left with 3, 4 and 5, right? 3, 4 and 5. Now what it has done, it has insert this 1, 1, 2 at position 2, right? So now once you insert it position 2, now your array would look like 3, 4, 1, 1, 2 and 5. 3, 4, 1, 1, 2 and 5, correct. Now in the second split and merge operation, what you can do, you can choose this subarray 4, 1, 1. So once you remove this 4, 1, 1, you will left with 3, 2 and 5, right? Now you can insert at position 3 at the last position. So your array would look like 3, 2 and 5 and then 4, 1, 1. Now the last operation is to choose 3, 2. Alright, I have chosen 3, 2, right? So you will left with 5, 4, 1, 1, correct. Now you can insert this 3, 2 at position 2, right? So your array would look like 5, 4, then 3, 2, then 1, 1, 5, 4, 3, 2, 1, 1. And if you see, this is my nums2, right? So you can transform nums1 to nums2 with 3 split and merge operation, right? Yeah. If you notice in the problem, the constraints are your n is only up to 6. So this kind of indicates that this is not a polynomial solution. It's going to be some 2 to the power n kind of solution, right? So yeah, let's see how we can approach it. In the third problem, we know that the size of the nums array is going to be at max 6, right? So the size is less than or equals to 6. So what we can do, we can apply a brute force approach, right? So the brute force approach would be just take any random subarray. So let's say this is my index 0, 1, 2, 3, 4 and 5, right? So let's say I have chosen this subarrays from index 2, 3 and 4. Now what you will left with 3 numbers, index 0, index 1 and index 5, right? So this is my leftover array. Now what we can do, we can apply this 2, 3 and 4 at any of the position. So the first possibilities could be, let's say I inserted at the beginning. So your possible arrays could be 2, 3, 4. So I'm writing down the index only, 2, 3 and 4 and then 0, 1, 2. This is one possibilities. The second possibility, let's say I started inserted between 0 and 1. Now your array would be 0. Now 2, 3, 4, 1, 5. third possibility, let's say I inserted between 1 and 5. So your array would be 0, 1. Then I inserted this chosen subarray 2, 3, 4, and then 5, right? And the last possibilities is, let's say I inserted at the end. So 0, 1, and 5. Then this removed 2, 3, 4, right? So these are the possibilities. Now let's say for this, like, to reach at this nums array, the total operation was ops, right? Number of split and merge operations. So to reach at these arrays, the total operation is going to be ops plus 1, right? Ops to reach at this stage, now one extra operation to reach at these many possibilities, right? Ops plus 1, right? Again we will try to do the same. Again we will to choose some random subarrays. One thing, maybe I have chosen 2, 3, and 4, but I could have chosen 0, 1, and 2 also, right? So we will go through all possible ways to choose, right? So from index for I equals to 0, I less than n minus 1, from j equals to I, j is less than or equals to n minus 1, right? So we will go through all possible ways of choosing subarrays. Now we will remove it, we will insert at any position. Again we will try to find the minimum number of ways to reach at nums minus the nums2 array, right? So yeah, this is a brute force approach. It's just an implementation problem. So let's directly look at the code. You would understand it better, I'm sure, right? So yeah, this is the code. So this is my nums1 array, this is my nums2 array, this is my size is, we know that the size is going to be at max 6, and I'll come to the dp array after some time. So now what I have done, so one more thing, if you have noticed, see, the initial array was 0, 1, 2, 3, 5, 3, 4, and 5, right? So if you notice here, 0, 1, 2, 3, 4, 5 is again present, so it's a repetition. So what you are doing, essentially you are going from state x to some different state, right? Some different state. So let's say since this is a kind of DFS approach or recursive approach, right? So it might be possible that after certain stage you again reach to the original state, like how the array look like. So after doing one operation, let's say you reach to the state which is already visited or explored, so don't do the exploration again, otherwise it will be a loop. So from state you reach to some other state, again from that state to reach, you have reached to this state, so it would be a loop. So don't visit a state that is already visited, right? That is the reason I have taken a set. So this set essentially stores all the state of the array, so that way you won't be doing a repetition. Like, so if the state is already visited, don't explore or don't do a DFS from that state, because that is already explored. So initially this is with this visited set would contain the original array nums1. Now I'm calling this solve function. So this solve function essentially gives me the minimum operation to reach at nums2, right? So yeah, this is my solve function. This is a lambda function, by the way. So now if my nums array is already nums2, just return 0, because like your current nums is anyway nums2, so like you don't need to do any operation, so return 0. Now if you have solved any DP problem, you might understand this, that I have stored the answer for the current state to some DP array. So it's it's an array, it's a map, because I have to kind of map from state to integer. So I just check if the DP contains the current state. If that contains, just return that answer, because it means that I have already explored it and I know the answer for that state. So just take it from the DP array. Otherwise, if it is not present, I'll calculate it. And how I'm going to calculate? So this is my original answer, int max. So it's 10 to the power 9. Now I'm going through each possible ways to choose a subarray. So this is my I is my left index, j is my right index, right? Now once you remove all the numbers from I to j, you will left with this remaining array. Let's say this is my remaining array. So I'll insert all the numbers which is left over by removing I to j. So this is the numbers present before I, and this is the numbers present after j, right? This is my size. What I'm doing here now, I am inserting this taken number from I to j at all the positions. So in the problem statement, what I have done here, I have taken first this L to R. Now what I'm doing here, I'm inserting at all possible positions, right? So there are 4 states possible, right? So that's what I'm doing here. I have taken I to j. Now I'm inserting at all the positions, k positions. So let's say this is my final temporary array. So this temporary array would contain the previous numbers, then all the numbers from I to j, and then all the afterwards number. So, and this size must be n, right? I mean, after doing all the operation, your size should be exactly the same. Your size shouldn't be changed. Now this is my final, like the next state, I would say. So my current state was nums, and this is my next state of the array, right? Now what I'm checking here, I'm just checking if it is not present in the visible arrays, like, so I'm just checking because I don't want to do in a loop, so it would be a kind of recursive infinite loop. So just check if that is not already explored. If that is not explored, your just insert it to the visited set. Now your answer is going to be minimum of answer comma 1 plus, because 1 means you are doing one operation to reach at the next state, plus the same solve function. This is the solve function that would give me the minimum operation to reach from this state to nums2, like to transform this temp to nums2, right? And just remove it because you have to do it, so it's kind of backtracking mechanism. So just insert it and then remove it, right, from the backtrack, and at the end just store the number, like you store the answer from the dp array and just return it. So like you could have also done it like first store, so dp of nums equals to answer, then return answer, like, so both are exactly the same. It's just a one line way of doing the same thing. So it's kind of, I would say, a combination of dp plus backtracking. So I would highly recommend to solve at least one backtracking problem and at least one dp problem, so then you would understand what I'm doing here, right? So yeah, this is the code of third problem. Now let's look at the fourth problem. This is the fourth problem asked in today's content. So I would say this is a harder version of the second problem. So in the second problem, your chosen subarray could be same also, right? For there could be repeated chosen subarrays, but here the catch is you cannot choose the exact same subarray multiple number of times. So it's not possible to choose the same subarray more than once, right? Otherwise the problem statement is exactly the same. So you are given nums array of size n and k. Now you have to choose k distinct non-empty subarrays, right? They could be overlapping, but they cannot be repeated more than once. Now we know that the value of a subarray is the difference between the max element from the subarray and the minimum element from the subarray. Now the total value is the sum of all the values of the chosen subarrays, right? And we have to find out the maximum possible total value which you can achieve, right? So yeah, let's see how we can approach this. In the fourth problem, let's say this is my nums array, right? And we have to divide this nums array into k non-empty subarrays, such that each of these subarrays may be overlapping, but like two of the chosen subarray shouldn't be the same, like they should be different. Now what is the brute force approach? If you think about the brute force approach, it would be go through all possible subarrays, right? Go through all possible subarrays, but uh, the two subarrays shouldn't be repeated, right? So it means that, let's say you started from int I equals to 0. Let's say this is my left index, l is equal to 0, right? L is less than or equals to n minus 1 l plus plus, right? This is my left index. Now the right index is int r equals to l r is less than or equals to n minus 1 r plus plus, right? So this way you would get a subarray from nums index L to R, right? And it is guaranteed that all these subarrays are non-repeated, they are unique, right? So what we can do, we can find the value of each of these subarrays. So the value of this subarray is the maximum value from this L to R minus minimum from this L to R, right? So then let's say I have taken a priority queue, right? Priority queue because I have to take the k I have to choose k subarrays such that the we know that the total sum is going to be the sum of all the v1 v2 v3 v4, right? So it's better to choose k max numbers, numbers from the priority queue. So what I'll do, I'll find a value, let's say this is vi. I'll insert it into the priority queue, right? So at the end this priority queue would contain n minus 1 divided by 2, right? Because there are n minus 2 number of subarrays possible, right? So it would contain n minus 2 values. Now what I'll do, I'll take the max k values from the subarrays. So this way it would be guaranteed that all the chosen subarrays are unique, right? Because I've inserted the unique values, like the values of from the unique subarrays, right? I'll take the k max numbers. But the problem with this approach is that the complexity is order of n square, right? Order of n square, because we are going through all possible subarrays. Maybe order of n cube, but let's say for all these subarrays you want to find out the mean and max, right? That would also take order of n. But let's suppose you have some other very huge algorithm that essentially gives you in order of 1, but still you have order of n square that you cannot reduce it, right? So how we can approach it, how we can do this better? So we can do it using segment tree, because we know that there are some range, we have to find out the minimum and maximum from some range, right? So that's kind of, in the contest, from that approach, from that way, I could figure it out that this problem can also be solved using segment tree, because we have to find out the mean and maximum from some range, right? And we have a very famous algorithm, range max query, RMQ, using segment tree, right? So let's see how we can approach this problem using segment tree, right? So what I'll be doing first, I'll have a priority queue, no doubt, priority queue, right? Now initially, let's say this is my 0 1 2 n minus 1, like this is the index. Initially I'll insert all the values of the subarrays from index 0 to 0, 0 to 1, 0 to 2, 0 to 3, and up till 0 to n minus 1, right? I'll insert all these subarrays, right, into the priority queue. Now what I'll do, one thing I would like to say, let's say you have a subarray from index some L to R, right? Let's say I'm saying that this is the, let's say this is you want to choose k subarrays, right? Let's say this k subarrays contains one of the subarray that is from L to R, the optimal k, right? First that you get the maximum value possible. Can I say, let's say I have another subarray that is from index, let's say some left index, let's say this is my left index and this is my right index, right? Can I say, if this is present in the array, can I say this will also be present in the array? It is guaranteed, because we know that if the subarrays from L to R is present in this k chosen subarrays, right? It means that the value of this subarrays is from the top k values, from the top k subarrays, right? If it is from the top k subarrays, then only it will be present in this k list, k chosen subarrays. I can guarantee that all these subarrays would also be present in one of the k subarrays, because you know that the condition is they could be overlapping. There is no problem with the overlapping. The problem only arises when they are duplicates, and I know that these two are not duplicate. So it means that if this is present, this must also be present in the given array. That is why instead, so in the brute force approach, what we were doing, we were blindly inserting all the subarrays into the priority queue. But here we will do something smart. We will start from the bigger subarrays, and we will like we will try to reduce the length by one each number of times, because we know that if the sorter, like if the smaller subarrays would is present in the k list, larger would definitely present, right? Because the larger will anyway contain this mean and max. So for the difference cannot be reduced by taking the larger subarrays compared to smaller one. So here what I will do, I will first insert all these subarrays, this from index 0 to 0, 0 to 1, 0 to 2, 0 to n minus 1 up till in the priority queue. Now what I'll do, I'll take the max value, like I'll take the max from the priority queue. Let's say the index is L and R, right? I'll take it, let's say this is LR and value. So first step, your answer plus equals to value, I will definitely take it. The second operation, just reduce the length. It is up to you, either you reduce the length by one from left or from right. So if you reduce the length from left, now the next value which you would be inserting is from L plus 1 to R. If you are taking, like if you are removing the element from the left, otherwise, or you can also reduce from R L to R minus 1, right? I'll insert like either one of them, it's up to you. Just insert the value and the index from the into the priority queue, right? And so on until you choose in until you have chosen the k max subarrays, right? That's all. And one thing, to insert from like to find the maximum value from any range, you would have you must have the priority queue, sorry, segment tree. Like you must find the mean and max. So because we know that the value is going to be minimum, like the maximum from this subarray minus minimum, right? And to find the mean and max from a subarray or any sort of range, you can use a segment tree, right? So yeah, I hope you have understand this problem. I would highly recommend to watch this video once again if you have not understand. This is not very hard problem. It's just algorithm could be hard, maybe segment tree I'm using, but the thinking, the logic is not that hard, right? So let's see the code now. This is the code. This is my segment tree. So for this is my way of implementing segment tree. It could be yours also, so it could be different for yours. So I would highly recommend to write your version of segment tree, how you write a segment tree to solve any problem. So what is important in the segment tree, because earlier it was either max and mean, but here I want both. I want both the information, max value and the mean value from the range, because to find the value is max minus mean, right? So I have implemented segment tree to find both max and mean. So query max and query mean. I'm not going to explain this part. This is my way of implementing segment tree. I would highly recommend to write your version of a way of writing segment tree, right? So I will directly come to the point. So this is my nums array, this is my k, right? So this is how I have built the segment tree. Now this is the priority queue. In priority queue, I'll store three information: value, left index and right index, right? So initially what I have done, I have inserted value for index I to n minus 1. So it is from 0 to 0, 0 to 1, 0 to 2 up till 0 to n minus 1, right? Now this is my answer. Now I only want to choose k maximum subarrays. So while k minus minus, I'll take the top value. So the top value would be the max value from the priority queue. I'll take it, I'll remove it, I'll increment my answer plus equals to value. Now what I'm doing, I'm just reducing one size of this subarray. So you can either remove it from left or from right. I have removed it from right. So for L to R, if you remove the rightmost number, you will left with index L to R minus 1. So just check if L is not equals to R, means if there is at least two numbers. If that is true, just insert the value from L to R minus 1. So value is maximum value from L to R minus 1 and the mean value from L to R minus 1, and insert it into the priority queue, right? That's it, and return your answer. So yeah, this is the code of fourth problem. If you have any doubt, please write a comment. I'll answer each one of them, right? So yeah, if you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.